Okay, so an introduction to multiplication. All right, you guys excited? Everybody's excited. They're all smiling behind their cameras. So what is multiplication? Our first question, what is multiplication? You're gonna have to explain this to your students at some point, probably like the third grade. Some people might ask it before third grade. And you see like, okay, well, what is multiplication? You have to define it. So take a couple minutes, not a couple minutes, take like a minute and look it up on your phone or your computer. And we're gonna see what you think about the internet's definition of multiplication. See if we need to simplify it at all or use simpler words, because we're gonna talk to elementary kids and not like regular people that are older adults. What is multiplication? Multiplication means what? So when you find something, go ahead and share it with our group.
I Googled it, Dr. B, and it says the process or skill of multiplying, the process of combining matrix, vectors, or other quantities under specific rules to obtain their product.
Oh, fantastic. So that had a lot of words in there. What do you think about that one?
I would just keep it at metrics. Would that be correct? The process of combining metrics or other quantities under specific rules to obtain their product makes more sense to me.
So in previous operations, we were talking about what's a good definition for addition or subtraction from K through 12. What you've done is you've cited a great definition for multiplication K through 20 or something like that, including college, which is awesome. But we're gonna kind of need to refine it a little bit to just talk about elementary.
I found one that says it's repeated addition.
Okay. And Camille shared that it's instead of repeated addition, we do like 2 times. It's like 2, instead of 2 added to itself 4 times, we do 2 times 4. Okay. All right, so what you've brought up is a lot of people have multiplication as repeated addition. You brought up kind of a little bit of a sticky point in math education. So math educators like myself debate what, or even other people debate what multiplication is, or if it is repeated addition or what. So we will talk about this is what we'll talk about it now too. Okay, so multiplication is, anybody else have any other thoughts from the internet or anything they found before we move on? Nobody else looked it up, or everybody else found the same answer?
Yeah, it comes up the same thing on Google.
Okay. All right. What we want to do, we'll talk about the repeated addition part. Let's see. Let's talk about it now, because it'll guide us to our definition. One way to start to get to understanding what multiplication is you can do repeated addition activities where we think about something like Camilla had used 2 plus 2 plus 2. So let's do that one.
Nothing showing on the iPad.
Okay. All right. Sometimes when I go to a different screen, like the chat screen, it kind of messes up the share screen. So we'll go back and reshare it. Thank you for letting me know. Okay, so this is a repeated addition example. And we're thinking about, is it repeated addition? Okay. And I'm going to write it as 4 times 2. Okay. So are those the same thing? Well, the sticky point for, here I have 4 2's added together. Sticky point for math educators is when we get to things like this. Fractions. That will equal 2. I have 4 halves added together. Okay. So we can do those. But what happens when we get to this, something like this? How would I write this as repeated addition? Okay, this is still a multiplication problem. Okay. What would this look like as repeated addition? I don't even have a whole number of halves to add together, much less multiple halves to add together.
It looks like you did 3 times 1 and 4 times 2.
Yeah, that's the algorithm to solve it, but we're focusing on the process.
I would assume that it's been simplified, and so finding the common denominator would make it easy to do an addition.
We need to think about these as just single quantities.
So 4 plus 4, right? Has the repeated addition. And then it would just be 3. Or am I crazy?
If you're thinking them as, when you take the 4 plus 4, you're thinking about just this part right here. Okay, that's taking it out of context for a conceptual idea of what this means. What does it mean to multiply 3/4 times a half? Okay. You're pulling the numbers out of context, or out of the context, so that you can find the answer. Yes, that's how you find the answer. What does multiplication mean? We're going just really broad and really top level. There's no way I can do repeated addition with 3/4 and a half. There's not like for this one I added half. On this one I added a half to itself 4 times, right? I cannot add a half to itself 3/4 of a time. That's like, time is like once instances. And so there's like 1, 2, it's very, they call it discrete numbers, where there's no fractions, no decimals. Okay. So that's the hard part. And with the core standards, they talk about, they have a different definition of multiplication. So we're going to go ahead and just look at that one for now. You can start by thinking about repeated addition, and you can make connections to repeated addition, but it won't work. If you look at multiplication as repeated addition, it won't work through all types of numbers. Okay, so when you start out talking about repeated addition as multiplication, as a way to calculate the repeated addition problem, you need to talk to your students about, well, this doesn't work all the time this doesn't work for all types of numbers. We'll start out here, and then we need to develop a definition more like the one in the core standards, or what people have been researching across the world. Okay? And Phil is the best one to be consistent throughout K through 12 mathematics. The idea is to talk about multiplication as groups of objects. So multiplication means, or multiplication of a problem, we're going to give it A times B. Okay? That means the total in A groups of B objects. Now, yeah, okay. So this is the important part. Just think about it as A groups of B. Okay. Okay. A groups of B objects. You have a certain number of groups of objects. Okay. If we tie it back to our examples here, four groups of 2. Okay, that 4 groups of 2 make 8, right? So I'm focusing on the process and not the answer necessarily. So I'm actually going to delete that part. 4 groups of 2. This right here is 4 groups of 1/2. And so when we get to this part here, the fractional part, you can use fractions, parts of groups. So 3/4 of a group of 1/2. Okay? 3/4 of a group of 1/2. So you have 3/4 of 1/2. When we get to fraction multiplication, we'll see that 3/4 of a half will be easy to do pictorially because we've written it like this. Any questions so far? You guys are doing great. So the next part is what do we call the parts of a multiplication equation? As we had before, we used a multiply symbol, B equals C. Now you guys might have wondered, so the part of multiplication equation has three numbers to it. You guys might have wondered why we use the X for time sign, and then we later get rid of it. So in the book reading, they'll talk about that. I won't go into that now. But yeah, so you start out with, I don't know why they don't start out with like a dot or something. One of the great mysteries of elementary education in the United States. Anyway, we have a number of groups. So the A means number of groups or sets. Okay, because you can use, instead of using groups of objects, you can use sets of objects. Okay? So I like to use the word group, so that's why I put the set in parentheses. The B has the role of the number in each group. Or set. So you have A is the number of groups you have, B is the number in each group. Okay? And C is the total. Okay, so that's why the definition of multiplication is the total in A groups of B objects. Now what are the names of these types of numbers here? So in this part here, A and B are called the factors. Okay, so when you factor something, you guys have done that before. When you factor something, you're splitting it up, a total, into two numbers that multiply themselves. Okay? A and B are called factors. What's the answer to the multiplication problem called? You guys remember? Starts with a P.
Is it product?
Yeah, product. Okay. All right, so A and B are called factors, C is called product. Any questions on the parts of multiplication problem? Okay, the definition of multiplication? All right, so I'm going to be done with that. And we're going to go to PowerPoint. Okay, operation meaning. When we study operations in our arithmetic class, we study their meaning, and let's see. There we go. We study the meanings of the operations in a certain order. We explore the operations in a certain order. So this is the order that we try to stick with. We talk about the meaning of the operation and their properties, like commutative property and such like that. Then automaticity, which is when you learn the facts, like multiplication facts or addition facts. Then we talk about thinking strategies, and then we go to the standard algorithm. So we build conceptually all of our thinking of multiplication before we do the standard algorithm. That's last. And that's what we'll be doing through this unit. So here's some examples of multiplication. First, how many Dixie cups will fit into the pitcher? If you were to fill up the pitcher using Dixie cups, how many would they fit? We can imagine taking a cup and pouring it into the pitcher, taking another cup and pouring it in the pitcher. That's the addition perspective. Now, addition is useful when we want to combine objects together, but sometimes it becomes so tedious and so long that we don't want to do addition. We get tired of it. Okay? We need something more efficient, and that's where multiplication can help us. So if we were to count how many Dixie cups fit in the pitcher, and we use something like one of these solo cups that are red or blue, and we put 10 Dixie cups into the solo cup, then we can use multiplicative reasoning to find the total number of cups, Dixie cups that will fit into that pitcher, right? It'll be much faster to do multiples of the Dixie cups. So the solo cup will pour in like the equivalent of 10 Dixie cups at a time. That's multiplicative reasoning. That's how multiplication can help us. So we're thinking about what multiplication looks like in real life. We're thinking about the structure of multiplication. Okay, so it's not just repeated addition. There's more concepts to it than that. Example number 2. How would you figure out the area of this wall? So this is like the back wall in maybe somebody's basement or something, and you're going to paint it. Do an accent wall. And you want to find the area of the wall so you know how much paint to buy. Are we going to do it like this? They sell paint in area estimates of square feet. Keep on adding my square feet together. So I took one there, I put one there, one there. Is that the best way to find the area of this wall? Well, there's more efficient ways, right? We can do the same job with multiplication, where we do some objects there, groups of objects. There are 1, 2, 3, 4, 5, 6, 7, 8 groups there. And how many are in each group? There's where we have a grid. 1, 2, 3, 4, 5, 6. Okay? So this right here has 8 groups of 6. Okay? 8 groups of 6 squares there, square feet. And the multiplication is the easier way to take care of it. How many snap cubes are here? What do you guys think we should do to find the total number of snap cubes?
Place them in groups of 10.
Yeah. So you can place them into groups of 10. because we use base 10, right? So you can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 groups of 10 cubes. Okay? So multiplicative thinking is really, really useful. It's a very powerful tool. Do you guys feel the power? Yeah, you can. Can you feel it? No? Okay, let's try another example. Maybe you can feel it after this one. How many discs are the weight of the object? Okay, so I'm going to draw an object in here. Here's an object. We have a little planter with a tree in it. Okay, we're going to weigh it. And so we want to take the blue unit and put it in here, right? We want to do that one at a time?
It's hungry.
No, that would take a long time. So what you can do is you can take multiples of this. This is like maybe 5 blue chips. Okay.
When do we start trusting without the?
What's your question?
Also because I don't want to run around the house, but because we also have cats.
Okay.
Outside, I let him off leash in the backyard.
And we can use multiples to find our answer. So it's more than just repeat addition. The use of an equal size grouping device or an indirect measure to find the total is more efficient than adding. So here's the models of multiplication. Here I have 4 times 3. Remember that this number right here, what's that number? What's the role of that number? Oops, let me go down. Let's see. The role of the first number in a multiplication problem.
Number of groups.
Excellent. That's the number of groups. What's the role of this number?
How many in the group?
Right. That's how many in each group. So you have the number of groups and the number in each group. So that's why this model for multiplication is very useful, because you can see the number of groups and the number in each group. Okay, hold on, let me switch these numbers. Okay, forget I said 4 times 3. Now 4 times 3 and 3 times 4 are commutative, right? Multiplication is commutative, but for pictures and modeling, it does matter the order of the numbers. Okay, because what I want to say here is I want to show 3 groups of 4. Okay, so whoever I stole this PowerPoint from did a mistake there. But anyway, 3 groups of 4. This is what we call the set model. Set model means that we've done this with addition and subtraction. You just have objects there. They represent, this is a drawing of concrete objects. And so that's how you can start multiplication and teaching it. Here's another one. 3 groups of 4 are right here. Let's see here. If I circle these this way in this arrangement of squares, that could be 3 groups of 4 here. This is what we call an area model. Area model means that I'm going to measure square units. So I tile them in a nice arrangement, and I can count them by using multiplication. They'll talk more about this in 2020 geometry. If I take my set objects and I arrange them into rows and columns, okay, that's called an array. Okay, you can again see the 3 groups of 4 right here. Array is arrangement of objects into rows and columns. Okay, so we arrange a lot of objects into rows and columns so they can be counted easily. Where can you guys see arrays in real life?
A classroom.
Yeah, classroom. Anywhere else? Although when you get to your methods courses, they'll debate that if that's a good way to arrange your classroom. At least arrange your classroom.
I'm thinking practically, I'm thinking like an egg carton.
Yes, that's exactly right. Egg carton. Okay, egg cartons are arranged in arrays. Okay, so this is a new topic. We haven't specifically talked about what an array is. So I'm kind of trying to get an idea of where you guys can get a notion of what this is. What about like soda? 6-pack. Okay. What about a case of canned something? Canned beans. Okay. Any canned vegetables that come in cases, soup cases, so they're all like arranged in an array, so you can easily count them, ship them. Okay. So those are what arrays are. And you can arrange 3 groups of 4 into an array. This is the bar model. So notice that the bar length has been labeled as 4, and I have 3 of those bars. With multiplication, we're going to constantly say groups of objects, just so you can get an idea of what that means. It's a little bit more complicated than repeated addition, but it's more applicable to more situations than repeated addition is. So that's why we're going to just start out with groups of objects. All right, once we've talked about what the operation meaning is, we're going to do properties. Multiplication has many of the same properties as addition does, since it can be thought of in the sense as repeated addition. So a lot of those things work for addition. The first property is the commutative property of multiplication. Okay, can somebody give me an example with numbers or variables of what the commutative property of multiplication is?
Is that like 3 times 4 is the same as 4 times 3?
Yes. 3 times 4 is equal to 4 times 3. Now they are the same, but if we talk about the roles of the numbers, that does matter, that there is a difference. They have one of the other things that is evidence that students think about these two numbers in different ways, and you'll have to teach that 3 times 4 is the same as 4 times 3, is just the way that they have done research with students, elementary students, and they give them, a group of 3 groups of 4 objects and 4 groups of 3 objects, and they thought about them differently. So again, the roles of the numbers. The first one is the number of groups. Okay. The second one is the number in each group. 3 times 4 is the same as 4 times 3. Now what we want to do is we want to show it as a picture. Okay. How do we do it as a picture? Can somebody draw a picture and show it? Or how about somebody direct me, since I can only see like a few of your screens during this PowerPoint thing. How do I draw a picture of 3 times 4? Can somebody describe to me what that would be?
You could do 3 different groups of 4 cookies.
Okay, cookies. I'll represent cookies with circles. Okay, so I'm going to draw 4 cookies here. And there's one set of cookies. You put dots for like chocolate chips or maybe raisins if you like that. Well, they could be anything you want in there. Crickets or something. Just kidding about the bugs. And there's another group of 4 cookies. And here's another group of 4 cookies. Okay, it's 3 groups of 4. Now that's the same as 4 times 3, or 4 groups of 3. And sometimes I do like circles around them just to show you the groups. So I do 4 groups of 3. I have something like that, and I can circle them like this. Okay? That represents the same amount, even though the structure is different. And so that's why we can assign the first number to something in the second number, because they are different. So we're building a picture of the commutative property. And in those representations that were on the previous slide, you can do this with each one of them. In the homework, you'll do this, and you can do the set model or the rectangular array model. So the area model, I forgot to mention the area model and the rectangular array model. Go back. Notice that these are similar right here. Okay, the area model is just for units of measurement, okay, like square feet or square inches. The array can be arranged into, you can use feet or inches, or you can use balls or marbles or stars or anything like that. So the array is more general, area is more specific. So they're a little bit similar in that regard. So we've built a picture for the commutative property. Say what it means. Commutative property means, oh yeah, what does it mean? Very general comment about what it means. Can somebody share that? We'll write that here. The commutative property means what? A multiplication. Do you guys, are you guys being shy or do you not know?
This isn't a great example, but you can have the same result by moving the numbers around in the problem.
Great. So it doesn't matter how you multiply 2 numbers, right? Commutative property is switching. You can switch them. Good. Here's the next one, the associative property of multiplication. What is the associative property? We want to give an example using letters or numbers. Associative property. I also want to kind of get to what it means too.
So you do like 6 times 3 in parentheses times 2
Okay.
is the same as 6 times 3 times 2 in parentheses.
Great. So what you're doing there is you're switching parentheses, you're associating the first 2, the 6 times 3. Okay. And you get 18. So here's the process here. So use parentheses here. Here's a square bracket. 18 times 2 is next, which is equal to 36. Okay. if you do these two first, you're going to get 6 times 6, which is also equal to 36. Okay, so I have 3 numbers that I'm multiplying together, and it doesn't matter which 2 I multiply first. Okay. So that's the meaning of the associative property. Let's draw a picture. Okay. Let's see. Let's use simpler numbers. You're going to have to draw these as sets. So another example will be 2 groups of 3 groups of 5. Okay. That's the same as 2 times 3 times 5, or 6 groups of 5. Okay. There's a picture. The first one was 2 groups of 3 groups of 5. Okay, so I'm drawing my 3 groups of 5 first, and then I do that twice, okay? And this one is just 6 groups of 5. Okay. We are a little longer. And here's our picture. 2 groups of 3 groups of 5. So I'm going to draw 3 groups of 5. Let's do circles. Okay. So there is 3 groups of that. Put these big circles around them. So I'm going to group them together. And I need 2 of those. So there's 1 of those right here. And I'm going to draw another one inside here. Okay. This is the set model way. Okay. So I have 2 groups of 3 groups of 5 right here. Isn't multiplication cool that you can nest it? This is called nesting. You put like multiplication inside multiplication. Pretty fun, huh? That's where scientists get work with other dimensions and things like that. So we have 2 groups of 3 groups of 5. That's the same as 6 groups of 5. Okay. So you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. How many groups do I have? 1, 2, 3, 4, 5 groups of 5. And there's 6 groups of 5. Okay. All right, notice that those are the same. But with multiplication, I can count them a little bit differently. I can count them by all in 1, 2 times, or all at once. So those 2 are called the set models. So we get a set model of those ones. Of the associative property of multiplication. Everybody doing good so far? Questions? Anybody know what the identity means? Multiplicative identity, what's that?
Isn't it like 4 times 1?
That's a good suggestion. What do you guys think? Anybody else? Do you concur or disagree?
Yeah, that was. Go for it.
Yeah.
Oh, sorry. I was just asking if it was 0. Like you multiply by 0.
Multiplying by 1 or by 0? That's kind of what we're debating right now. What do you guys think? Anybody else have any thoughts?
I think it's by 1. Anything times by 1 is itself.
Okay. And why is that the identity and not the other one?
Because it's what it is. It's identity. I don't know. It's always the same.
Because when you think of addition, if you do 4 plus 0, it equals itself. So in multiplication to equal itself, it would be like 4 times 1 group of 4. Or like 1 group of 4 or 4 groups of 1.
Okay, and then Ariana had talked about multiplying 0. That's the next thing. Okay? So our goal is to kind of derive what that means. It's called the zero product rule. But first, the identity is what can I do to operate on a number to get the number back.
So I get it. I think I was thinking of addition, but you add 0 and end up with the same number. And with multiplication, you times it by 1 and end up with the same number.
Yes, yes, there you go. I got you now. So that's, yeah, so operating on addition. So if I add to 0, I get the same number back. If I operate on my identity, or a number for multiplication, I need to get the number back, and that is multiplied by 1. So for example, it's like a times 1 equals a. This is what they usually say. We can use another example with numbers. 4 times 0, oops, not 0, 4 times 1 equal to 4. Okay. So we want to make a picture of that. Remember, this is the number of groups. And that's the number in each group. Okay. So I have 4 groups of 1. Okay, so there's my little cookies. Okay, so I have 4 groups of 1 cookie. And so I can kind of like indicate that by like little squares or something. It's like I did before, little circles. That's the same as 4, which you can just draw 4, you know. Okay. 4. So the picture of the multiplicative identity is a little bit trickier to do, but that's kind of about what you're going for there. Okay, good. The last one is the zero product rule. Anybody have an idea what that could be, an example, using variables or numbers? Zero product rule.
And the product rule is anything times 0 equals 0.
Right. Okay, so I think my second daughter came to home one day from school, and I don't know if she was in the first or second grade, something like that, and she was talking about anything times 0, 0. And it was like second or third grade. But she was very proud of that because she's like, Dad, what's 2 times 0? Or she's like, I know what anything times 0 is, asking me questions. So I'm like, 2 times 0, 5 times 0. And so she knew what the answer was. She did this also with the additive identity. And so it was pretty neat to see that her excitement, that's knowing what that is. So the students can get excited about these things, where they have this general rule that they can apply to a bunch of situations and they can know the answer. Okay. So so that's the zero product rule. If a product, so that you can say like that, or you can say it sort of like this. If the product of 2 quantities is 0, then at least one of the quantities is 0. Now we write at least because you can actually have both of them be 0. Because a times 0 is 0. You can even have 0 times 0 is 0. You can have 0 times a is equal to 0. Okay? So this is important because we're going to connect it to division later. Okay? So you have nothing here. If you think about the roles of these numbers, A is the number of groups you have. So you have some number of groups, like 4 groups. But there's nothing in each group, then that means your answer is nothing. If you have no groups, but 5 in each group, but you don't have any of those groups, then that means your answer is nothing. And of course, if you have no objects in each group and there's no groups, or there's no groups and there's no objects in each group, then that means you have nothing as well. So it's kind of hard to draw pictures of this, I guess. We won't worry about that. Okay. There's one more property, and it relates to, I think we'll get to this later, figuring out 6 times 7. So 6 times 7 is one of the harder multiplication facts for students to get. How can they learn it? Using a property, okay? So here I have 6 times 7 rectangles. They're arranged in an array. But I can split my 7 up into 5 times 2. And we've actually done this before with our 30-second challenges.
Don't you mean 5 plus 2?
Yes, that's what I mean. If I said something else, forget what I said. So follow what I write, maybe. Okay, 7 became 5 plus 2. I can split that up, okay, into those 2 sum-ins or add-ins. So you can call it like addending or something like that instead of factoring. But anyway, we split that up. So where's 5 and 2 going to be split up? Let me see what the next slide is. 6 and 5 and 6 and 2. Okay, so I'm going to split this up right here. This distance right here is 7. And I split it up here into 5 units this way and 2 units that way. If I do that times 6, which means I'm getting some depth to it, some length, okay, I get this group here and this group here of squares, rectangles, can add together to get the total that I want. Okay, and here the diagram of them splitting it up. I have 6 times 5, 6 times 2. Okay, that's 30, and that's 12. And when you add 6, we know that 6 times 7 is 42. But if I can split it up into something easier, students know the 5's group table is easier, and they know the 2's easier. Okay. So what we call this property is the distributive property, and it's important because it combines addition and multiplication. It combines together division and subtraction, or addition and division, or multiplication and subtraction. You can do those in certain orders, so you gotta be careful. But you can distribute the A to the B by multiplication and to the C without adding B and C together. Sometimes you don't know what they are and you can't add them together. Sometimes you can. Pictorially, this is the whole thing, A and B and C. B and C is this distance here. And then you can split it up. Okay, and this is going to be A times B, and this is going to be A times C. And you can split it up into these two right here. So this is a picture. I can find the total number of area, total amount of area. This could be an area model, if you will, by splitting it up into parts. This is important because we use the distributive property when we multiply more than 1-digit numbers. So multiplying 2-digit numbers, 3 digits, and 4 digits. We use distributive property to help us because it's a lot of work to multiply that many digits, okay? Those higher numbers. Okay, so this is a key, and we like it a lot because it helped us, right? Good. So hopefully everybody's on board. You guys okay with the distributive property?
Yes.
All right. This is the learning outcomes that we covered. Definition of multiplication, modeling using sets, arrays, and areas and bars, and understanding the properties pictorially, verbally, and symbolically. All right, so we are at time. want to make sure that everybody's got any questions answered. That should be good to do the homework, reading. Everybody's just so excited. You just tell.
I'm actually good for now, but thank you for your time today. I appreciate you. Have a good day.
Yep, me too. Let me know if you guys have any questions on the homework.
Thank you, Dr. B.
Thank you.
You're welcome.
Dr. B, I do have a question for 3.1, if that's okay. If I could ask you about that.
Is it good for other people to be around and recording?
Yeah, no problem at all.
Go ahead.
Okay, so I'll turn on my video just in case. So I'm in my office, and where my video is, it looks like I'm looking up above you. So that's why I turned it off, because it doesn't look like I'm actually focusing.
Not a problem.
So, okay, on 2A, I'm coming up with a negative number.
Okay, so tell me which homework that is.
It's 5% of 800.
Okay, 5% of 800. Okay.
Yeah. So I'm wondering what I'm doing wrong, or if that's a possibility to have a negative number like that.
No, 5% is only a part of 800. And so 800 is all positive, so you have to be a positive number. And it's going to be a small number because 5% is really small compared to 100. And so those are good thoughts.
Okay, so what I did for my plan was, for the 800, I divided that by 100. And then that gives me 8. And then did -3 to get the 5%. Did I do that
No,
wrong?
you're comparing your number and the percent, and you're mixing those categories. If you divide 100, so you have 100% equals 800.
Right.
Those are the same. 100% arrow to 800. Dividing it by 100 will get you down to 1% arrow 8, right?
Yes.
Okay. I can write this out on the iPad, but you're following me okay still.
Yes. Yep, I'm following you.
What you need 5%. So you have to multiply the 1% by 5 to get to 5%.
Oh, that's where I did it wrong.
Mm-hmm.
Okay, I was thinking it the opposite way. Okay, that makes sense.
Yeah.
Okay.
Manipulating your 5%, 1% to 5%, and then you also do that by multiplying by 5. You also do that to your 8 because it has to follow suit.
So then I would have 5 arrow 40, right? Okay.
5% arrow 40. Labeling that percent will help you keep those straight.
Okay, I just had my 5 on the wrong side. That's what I did.
Okay.
Okay, thank you. That helps.
Hey,
okay. I think that's it. If not, I'll message you.
Sounds good. Have a great day.
Okay, thanks. You too.
Bye.